Alakaslı, and this is my machine learning CA project, and it's about predicting which adverts a person will click. Alright, imagine an advertiser meets a new user and has no click history to work with. Researchers suggest a shortcut: ask the person a few personality questions instead of waiting for their behavior. And this works in areas like, like music recommendation, but nobody had tested it properly on advertising. So I asked three questions. Does a deep model beat a classical one? Does personality beat plain demographics? And does representation learning help on small data? I used a public data called ADS16. It has 120 people, and each of them rated 300 real adverts. For every person, I know their Big Five personality scores. Big Five is standard personality model in psychology, measuring how open, organized, social, cooperative, and anxious someone is. So here it is, 10 short questions. I also know their age, income, gender, and job, and their favorite films and musics. So the design, I built a ladder with 4 levels. At the bottom, the model knows nothing about the user. Then I add demographics, then personality on its own, then both together. So the average site never changed. So if the score moves, I know the user information caused it. I ran all 4 levels with 3 models, and I split the data by person, so test users are strangers to the model. So each group is 1 level of the ladder, and 3 bars are the 3 models. The second group is demographics, that is where every model does best. The third group is personality on its own. 2 of the 3 models drop below the dotted line, and that line is the model that knows nothing about the user. So for those two, knowing someone's personality was worse than knowing nothing, actually. So what I found is demographics helped. Personality hurt is in almost every comparison. The deep network didn't win a single level. The autoencoder recovered part of what personality cost, but never caught up with demographics. I think the reason is size. Like I have 54 personality features, but only 84 people in learn from. The model finds accidents in those 84 people and applies them to new people. I think like demographics are also already there and cost nothing, so personality had to beat them, and it couldn't. And a few limits. The model only sees each adverts as a category, so it cannot tell 2 adverts in the same category apart. So I ran the pipeline twice rather than across many feeds, and I only tested on 18 people. So to finish, personality didn't pay for itself here. So for cheap demographics fields, beat 54 psychological features, and a simple model beat the deep one every time. And now let me show you the code. All right. The first two are set up the environment and load the dataset. It arrives into archive, so I joined them, and the notebook stops if it doesn't find all the people. Oh yeah, found all of them. So cell 4 was, oh wait. So cell 4 was the hard part. The rating file hides the data. Every cell looks like one number, but it actually holds 15. So, uh, how do you say? This loop unpacks it. So each person becomes 300 rows instead of 20. And Cell 5 builds the user features, personality, demographics, preferences, and the images they liked and disliked. And Cell 6 here splits the data by person, not by row. If I split rows, the same person would sit on both sides, and the model would just memorize them. Then my test score would be a lie. So Cell 7 is the advert site, and it is very short now. It used to be long. I tried 3 different ways to read the advert image, including a vision model and an API. Then I realized they were all trying to work out something the dataset already tells me, which is the category. So I used the category. And Cell 8 turns the preferences text into numbers. I fit this on training people only. Otherwise, information about the test people leaks into the model. So the cell 9 here joins everything into one table. Cell 10 holds the shared code that every experiment uses. So these cells, this 11, 12, and 12A and 12B, these cells run the experiment, 4 levels and 3 models. I'm waiting for it. It's gonna take a bit long. SPR is a bit different. It predicts the rating rather than the click, and that turns out to matter. Alright. And the cell 13 is the autoencoder, which compresses the user information. Cell 13B supposed to be here down there. Oh, wait. It's going to take a bit long time again. Oh, there we go. This one's also done. This cell 13B checks uh, checks whether class rating was worth nothing. And here is the result table, demographics. Wait. Oh, yeah. This is the result table. Here you go. As you can see, F1 is here. Demographics wins, and personality is the worst, one of the worst. And they all together is worst and worst. And the only personality is the worst one here. And here's 15. Cell 15 shows the arrows. Notice the same score repeating. The model gives one user the same answer for every advert in a category because it cannot see inside a category. So this is my design limit showing up in output. I ran the whole notebook twice. The classical models gave identical numbers. The deep model moved a little, so I put both runs in the report and dropped the 2 claims that didn't survive. And here's the answers. Right. Thanks so much.